Hello, welcome. Hope you're having a good day. Polynomial and rational inequalities. We'll first start with polynomial inequalities. A polynomial inequality is simply a polynomial equation which contains an inequality symbol. In this lesson, our goal is to find which values for x would make the inequality a true statement. Okay, here's our procedure. And we are writing this inequality on a number line. So it's not a two-dimensional graph, it's just on a number line. So step one, write the inequality with all terms in descending order, so highest degree term to lowest degree term, on the left-hand side, LHS left-hand side, and a 0 on the right-hand side. All right, so the x squared, and then the x, and then the constant, in that order. Or x to the third, and then x squared, and then x, and then the constant. Okay, second step is we're going to factor the polynomial on the left-hand side. Good old factoring, right? Then we're going to set all the factors equal to 0 and solve each equation. Each of these values we will call critical values. I don't know why we call them critical values, but that's usually what they're called. We're going to draw a number line, put these critical values on the number line, and what these critical values do is they split the number line into intervals. Okay, so if you have one critical value, then you have two intervals, the left and the right. If you have two critical values, then there's going to be three intervals or three sections, the left, the right, and the middle. Okay, so we're going to choose a number in each interval. We're going to write it down below the line in its interval, and these numbers are called test points. So we're going to choose a test point in each section or in each interval. So these are called test points. Then we're going to insert these values into the inequality. You could choose any row of your inequality. So you could either use the original or the factored form, totally up to you. I tend to use the factored form, but that's me. You don't have to. And then you're going to determine if it would be true or false. And you're going to place a T or an F above the line or below the line, or wherever you want, to show this fact. So you're going to show if it's true or false. Then we're going to shade or darken the number line on the true intervals. So we're shading the true. And if we have greater than or equal to or less than or equal to, we're going to use brackets at the critical values. And if it's a greater than or less than, we're going to use parentheses. The brackets are used to show that that number is included in the solution. The parentheses are used to show that that number is not included in the solution. And finally, we're going to write the answer in interval notation. I know a lot of notes here. You might want to pause the video so you can write all those notes down. Okay, here's our first example. We're going to graph this inequality, x squared minus 2x minus 48 greater than or equal to 0 on a number line, and then write the solution in interval notation. So first, we want to factor the left-hand side. Now also note that we already have a 0 on the right-hand side. So on the left-hand side, it's already written in descending order. On the right side, there's already a 0. So our next step then is to factor the left-hand side. I skipped the steps here. I think you're a factoring machine by now. So factor the left-hand side. That gives you x minus 8 times x plus 6. Now we're going to set each factor equal to 0 and find the critical values. So set x minus 8 equal to 0 and x plus 6 equal to 0. Solve those two equations. That gives you x equals 8 and x equals negative 6. Okay, make sure you have equals for the critical values. You don't want to write inequalities here. I know the original problem has an inequality, but when you write down our critical values, these are equals. Okay, so we're going to put these numbers on a number line. So there's our number line. Negative 6 should be on the left and 8 should be on the right. How many regions do we have, or how many intervals will we have here? There's 3. There's to the left of negative 6, there's between negative 6 and 8, and there's greater than 8. So 3 intervals here. Now we're going to pick a test point in each interval. So we want a number that's to the left of negative 6, negative 7, maybe negative 8. It can be any number. And then a number between negative 6 and 8, 0, 1, 2, negative 1, negative 2. And then another number to the right of 8, like 9. I wrote them above, so I'm picking negative 7, 0, and 9. And I put them in circles above the line to just not confuse them with the numbers that are on the number line, the negative 6 and 8. Okay. Now we're going to determine if it's true or false. So you're going to plug that negative 7. You could use the original problem or the factored form. I'm going to use the factored form. Now I already showed the work here. So I'm replacing x with negative 7, so that gives us negative 7 minus 8, negative 7 plus 6, negative 7 minus 8 is negative 15, negative 7 plus 6 is negative 1, then multiply the two numbers. Negative 15 times negative 1 is 15. Is this greater than or equal to 0? Is that true or false? Right, that's true. So we're going to put a little t next to it. Okay, let's do that with 0 and 9. Again, you might want to pause the video and work it out. Okay, so let's do 0. Again, go back to the factored form. Everywhere you see an x, replace that x with 0. Okay, there's our result. We get negative 48. Is that greater than or equal to 0? No, it's not. So that is false. All right, one more to do, 9. So plug in a 9 everywhere you see an x. The result is positive 15. Is this greater than or equal to 0? Yes. So that is true. So now we could go to our number line, and underneath negative 7, put a t. Underneath the 0, put a f. And underneath the 9, put a t. Now here's a little hint. Most of the time it'll alternate. It'll either go true, false, true, or false, true, false. Now I said most of the time, and that's because the factors don't have any exponents other than 1. If there was, let's say, a squared outside the 8, after the 8, and let's say it was x minus 8 all squared, then that rule does not apply. So just keep that in mind, that normally or usually it alternates, but not always. All right, let's shade the true intervals. So shade to the left of -6 and greater than 8. Now we're going to use brackets or parentheses. Right, we're going to use brackets since we have the equals. And now write that in interval notation and we're all done. And so there's our answer, -infinity to -6, brackets, union, 8 to infinity, brackets on the 8, brackets on the -6. Infinity always has parentheses, right? All right, that's it. Let's do the next one. Okay, number 2. Graph the inequality 2x squared minus 5x less than 12 on a number line. Then write the solution in interval notation. So what's different about this problem than the last problem? Right, there's not a 0 on the right-hand side. So that's the first thing we need to do, is get a 0 on the right-hand side by subtracting 12 on each side. So if we subtract 12 on both sides, then we end up with 2x squared minus 5x minus 12 less than 0. The left-hand side is in order. Now we just need to factor it. Why don't you pause the video and factor that trinomial with whatever method you use. All right, so that factors to 2x plus 3 times x minus 4. If you do the grouping, multiply 2 times -12 and you get -24, and then find the right pair that subtracts to give you -5, which is 8 and 3. Okay, let's move on. Next thing to do is to find the critical values. So set each factor equal to 0, so not less than 0. Each one is equal to 0. So 2x plus 3 equals 0, and x minus 4 equals 0. Okay, again, pause the video and work those out. All right, so if you subtract 3 on both sides and then divide by 2, you'll get -3/2. And the one on the right, just add 4 to both sides, and you end up with x equals 4. Okay, those two numbers are written on a number line with 2 tick marks. Try to space them away, Then pick critical values in each region. -3/2 is the same as -1/2. So anything to the left of -1/2, -2, -3, and then a number between -3/2 and 4, and then a number greater than 4. So I chose -2, 0, and 5. Okay, now we're going to plug each of those in. I'm going to use the factored form when I plug each number in. All right, so plug in -2. There's the result. So again, we're replacing x with -2. So it's 2 times -2 plus 3 in the first parentheses, and then -2 minus 4. So that'll give you a +6, which is not less than 0. So that should be a false. All right, now do the same thing. Replace x with 0. And you get -12 is less than 0. That is true. -12 is less than 0. And last one, replace x with 5. So we're using the factored form, the 2x plus 3 times the x minus 4. And we're simply replacing x with 5. We end up with 13 is less than 0. That is false. Okay, so it's going to go false, true, false. Shade the true. Which one is true? Right in the middle. So shade the middle. And then are we going to use brackets or parentheses? Yeah, it's a less than. There's no equal sign. So this one will be parentheses. Now we'll write that in interval notation. So there's our answer. Parentheses, -3/2 to 4. Close parentheses. Our next example, 2x to the third minus 2x squared minus 24x greater than or equal to 0. This one looks more complicated, right? Yeah, a little. Okay, we already have 0 on the right-hand side. That's good. It's already in descending order. That's good. So we just need to factor the left-hand side. So when we factor, let's see, what should we do first? Right, GCF. What is our GCF? Let's see, 2 goes into all three terms and they all have an x. So you're going to factor out a 2x. So put 2x in front of parentheses and then divide each term by 2x. And write the result inside the parentheses. Okay, so that gives us 2x. And then parentheses x squared minus x minus 12. Close parentheses. All right, now inside the parentheses, the trinomial, we need to factor that. So we'll just bring the 2x down after we factor that trinomial. Yeah, 12, the factors of 12, let's see, 2 and 6, 3 and 4. Right, 3 and 4. A minus 4 and a plus 3, that'll work. So there we've done it. There's our factored form. 2x times x minus 4 times x plus 3. Set each factor equal to 0. And then solve each equation. We're going to have 3 critical values. Divide by 2 on the first one on each side, and we get x equals 0. Add 4 to both sides, x equals 4. And subtract 3 on both sides, x equals -3. Let's put those on a number line. Make sure you put them in order. So the -3 should be on the left, 0 in the middle, and 4 on the right. How many intervals do we have? Or how many regions exist? Right, there's 4 regions. We have 3 critical values and 4 regions. Yes, more work. We're going to have to pick more test points. So to the left of -3, in between -3 and 0, and you could pick different numbers than I do. It doesn't really matter, as long as it's a number within that region. So here are the numbers I'm going to choose: -5, -1, 2, and +5. Again, when you plug those test points in, you could use any row. You could actually use the very original row, the 2x cubed minus 2x squared minus 24x greater than or equal to 0. You could use that row and then replace each number in. or I'm going to use the factored row. Totally up to you. All right, you know how to do this, so go ahead and pause the video and work out each one. And again, it should go either true, false, or false, true, false, true. All right, here's the first one. I got negative 180 greater than or equal to 0. That's a false. For negative 1, I got 20 greater than or equal to 0. That's true. For positive 2, I got negative 40 greater than or equal to 0. False. And last but not least, 5, 80 greater than or equal to 0. That's true. So it does go false, true, false, true. I didn't really go through all that. I think you should be okay going through each step. Okay, so it goes false, true, false, true. So which ones are you going to shade? Well, we shade the true, right? So you're going to shade between negative 3 and 0 and greater than 4. And then brackets or parentheses? Right, brackets. So now write that in interval notation. So we're going to have two separate intervals joined by a union. The first one is from negative 3 to 0 with brackets. And then the second one is from 4 to infinity, brackets at the 4, parentheses at the infinity. Okay, we're going to be graphing rational inequalities. So it's a rational equation that just contains an inequality symbol. Rational means fractions. So we're talking about fractions. Here's some examples. X plus 5 over x minus 2 greater than 0. 2x over x minus 3 less than or equal to 4. Okay, we're still trying to find the values for x, which would make the inequality a true statement. Here's our procedure. It's very similar to the last one, except there's no factoring and a couple of little things. Okay, number one, we're going to write the inequality with a 0 on the right-hand side. So we have to get that 0 on the right-hand side. Same as last time. We're going to set both numerator and denominator equal to 0 to find the critical values. We're going to do the same steps, which means we're going to pick test points in each region and determine if it's true or false. And again, we will darken the true. Number 4, if it's greater than or less than, we're going to use parentheses. If it's got the equals, we're going to use brackets. Okay, this is a big but though. However, a rational expression cannot have 0 in the denominator. Therefore, the critical value which is obtained by setting the denominator equal to 0 can never be included in the solution. So parentheses will always be used at the critical value from the denominator. Okay, I know that's a lot. When we use brackets, brackets are used to include that number in the solution. But we can't have 0 in the denominator. What is it called when we have 0 in the denominator? Right, it's called undefined. So whatever number we obtain from the denominator is always going to be parentheses. The critical value from the numerator will have brackets if there's a less than or equal to or greater than or equal to. But the denominator critical value is always parentheses. Okay, and then last we're going to write that in interval notation. All right, let's do it. Two x minus 5 over x plus 3 less than or equal to 0. All right, cool. The good news here is there's already a 0 on the right-hand side. That's one less step to worry about, right? We need to set each numerator and denominator equal to 0 and solve. So 2x minus 5 equals 0 and x plus 3 equals 0. Now solve each equation. The one on the left, add 5 to both sides, then divide by 2, 5 halves. And on the right, subtract 3 on both sides. I apologize for not showing all the steps, but there's so much to put on the screen here. I try to minimize it a little bit. I think you got it anyways. All right, put those two numbers, our critical values, on a number line. And pick a point in each region, something less than -3. In between the two numbers, 5 halves is 2 1/2, so a number bigger than 2 1/2 on the right, maybe 3. All right, now we're going to insert each of those to determine if true or false into the inequality. We'll start with -4. Again, I think you could do this. Replace each x with a -4. Pause the video and work it out. All right, here we go. So 2 times -4 minus 5 over -4 plus 3. The top simplifies to -13. 2 times -4 is -8. Minus 5, and that gives us -13. On the bottom, -4 plus 3 is -1. And then we have two negatives, which turns into a positive. And 13 over 1 is 13. So 13 less than or equal to 0? No, right? That's false. All right, let's do the next one. Let's plug in 0. Again, replace each x with 0. So 2 times 0 minus 5 over 0 plus 3. 2 times 0 is 0, and 0 minus 5 is -5. So we got -5 on top and 3 on the bottom. It's a negative number. Less than 0? Yeah, it's less than 0. True. One last number. What should it? The answer should be what? True or false? Yeah, I already gave you the secret, right? It's going to be false, but let's do it anyways. 3. Again, replace each x with a 3. 2 times 3 is 6, and 6 minus 5 is 1. We get 1 on top. And 3 plus 3 is 6. 6 on the bottom, so 1, 6. Smaller than 0? No, false. So there's that pattern. False, true, false. So in this video, the examples we've chosen, it's going to alternate. That doesn't mean it happens all the time. Just kind of be aware of that. Whenever you have squares involved or exponents around the parentheses, around the numerator, denominator, multiple factors, then those rules don't apply. Okay, so we're going to shade in the middle. And then don't forget, it says brackets because it's less than or equal to 0. So we want to use brackets. However, the critical value from the denominator has to be parentheses. Which number came from the denominator? Right, the -3. So the -3 must be parentheses. If you write brackets for your answer, it's going to be marked off. So it has to be parentheses, -3, comma, 5 halves, brackets. Okay, next example, 5x over x minus 2 greater than 3. What's different? Right, we do not have a 0 on the right-hand side. So we got to get a 0 on the right-hand side. So what we're going to do is subtract 3 on both sides. If you subtract 3 on both sides, well, this is what we get. 5x over x minus 2 minus 3 greater than 0. Let's put a 1 underneath the 3. And then you're going to need to get a common denominator because we have to make the fractions have the same denominator. We need an LCD. Well, in this case, it's going to be x minus 2. So the numerator and denominator of 3 over 1 is going to need an x minus 2. Okay, so I put a 1 underneath the 3. And we need to make the denominators match. So whatever the denominator is underneath the 5x, which is x minus 2, whatever that denominator is, then that's what our next fraction is going to need because it's only a 1. So it needs an x minus 2 on the bottom, but whatever you do to the bottom, you got to do to the top, right? Okay, now we're going to distribute and keep it all over x minus 2 because the denominators are both the same. So you're going to have to distribute the 3, but it's not a 3. Be careful, it's a negative 3. So distribute that negative 3. So if you distribute the negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. A lot of people will forget to distribute the negative, and then you'll have a minus 6 there. You don't want a wrong answer. All right, so here we go. We have 5x minus 3x. We can combine like terms. That's 2x, so we have 2x plus 6 over x minus 2 greater than 0. All right, so now we got our 0 on the right. It does factor to give us 2 times x plus 3, but that won't reduce with anything in the denominator, so we're not going to bother doing that. Okay, so find your critical values. Set both numerator and denominator equal to 0, and solve. So on the left we get negative 3. If you subtract 6 on both sides and then divide by 2, we'll get negative 3. And on the right, add 2 to both sides. So those are our two critical values, negative 3 and 2. Place those on a number line. That separates it into 3 regions. Now pick our test points. I'm choosing negative 4, 0, and 3. I try to pick 0 whenever I can because it's the easiest one to work out. All right, let's do it. You know the process. Plug in negative 4. I'm going to use that last inequality, the 2x plus 6 over x minus 2. But you could use the 5x over x minus 2 greater than 3 if you want to. You just have to figure out if it's true or false. It'll still give you the same result, just different numbers. All right, 2 times negative 4 plus 6 over negative 4 minus 2. 2 times negative 4 is negative 8. Negative 8 plus 6 is negative 2. So we got negative 2 on top. And negative 4 minus 2 is negative 6 on the bottom. And that reduces to 1/3 positive. So that's greater than 0. Let's plug in 0. So again, everywhere you see an x, replace it with 0. 2 times 0 is 0. And 0 plus 6 is 6. So we got 6 on top. And 0 minus 2 is negative 2. Negative 2 in the denominator. 6 divided by negative 2 is negative 3. Greater than 0? No. So that's false. All right, one more. What are we going to plug in? X equals 3. So let's plug in x equals 3. So 2 times 3 plus 6. That's 6 plus 6, which is 12 on top. And 3 minus 2 is 1. Anything over 1 is the same thing, so we get 12. Greater than 0? Yeah. So that's true. So this pattern goes true, false, true. So we're going to shade the trues. And we're going to use parentheses when we shade it. We don't need to worry about which one comes from the critical value because they're both parentheses. So then our answer will be negative infinity to negative 3 union 2 to infinity, all parentheses. All right, that was the last example. I'll see you here for the next one. Have a good day.